let's come back to the techniques. We've learned the substitution method. Let's move on to the next method. We saw that these questions we were not able to solve it by direct substitution. That means we require some new techniques, some new methods. Now people have worked and they found out that factorization helps us to some extent. So let's again look at the same two questions. Limit of x square minus 1 upon x minus 1. Direct substitution did not work for this. The second method is try to factorize stuff. So whatever the value of x is tending to, that gives us a hint. That might be a factor. So yeah, let's use factorization to find the limit of this question. The denominator is pretty much factorized already. It has one factor, x minus 1. There's only one factor there. The second term, a square minus b square, is equal to a plus b into a minus b, isn't it? That's how we factorize the numerator. We have to find its limit. We'll substitute. We'll eventually have to substitute the value of x. But first, we'll simplify the function. What we get is limit x tending 1, x minus 1 gets cancelled. We have x plus 1 here. So what we've done here is we had a function, let's call it f of x. And we represented this, we simplified using factorization, and we kind of represented it as another function g of x. Now I'll show you why f of x is not exactly the same as g of x. We'll talk about that. But for now, it's very much similar to g of x. F of x is very much similar to g of x. It will help us find out the limit. Let's continue finding out the limit. Limit x tending to 1, x plus 1. You just have to substitute now. See, factorization plus substitution. Substitution is the last step. You'll always have to do that. So this you will substitute. If you substitute the value of x, you get this as the limit. So this is your answer here. The limit of the first question, the limit of f of x, we found out as 2. Let's look at the second question. Can you factorize the numerator? I hope you have attempted this. You've tried to factorize it. And once you do that, let me quickly do it for you, okay? So x square minus 2x minus 4x plus 8 upon x minus 2. This will give you x minus 2 and then x minus 4. Okay, and here you have x minus 2. We are simplifying the function, of course. Limit x tends to 2 is always going to be there. Do not forget to put in the limits. Or you can separately simplify the functions and then put it under the limit bracket, under the limit umbrella finally. So this x minus 2 and x minus 2 get cancelled, and what we have is x minus 4. Again, final step is substitute. Substitute, direct substitution is needed then. So this is equal to 2 minus 4, which is minus of 2. So that's the limit of the second function. So factorization is another technique which helps us find out the limit. What did we see? That, first we'll try direct substitution. If direct substitution is not working, if direct substitution is giving us indeterminate forms, we try different methods. The first method, apart from direct substitution, is this, factorization. Sometimes you'll have to factorize the numerator, sometimes you'll have to factorize the denominator, depends on the question. Let's move on. I did tell you that we are going to discuss whether the function, this function and this function are the same or not, are exactly the same or not. Now, these are different functions than what we considered here. Here we had x square minus 1 upon x minus 1, and here we have x cube minus 1 upon x minus 1. I hope everyone remembers the expansion of a cube minus b cube. So if we have x cube minus 1 upon x minus 1, which is denoted as f of x, which is also plotted, I'll show you why this point is missing here. Because this function f of x is not defined at x equal to 1. That's why you see a hollow circle there. This function is not defined at that point. But if we try to write this, simplify this algebraically, manipulate this algebraically, we come to the conclusion that, okay, a cube minus b cube. So x cube minus 1 cube is x minus 1 into a square plus ab plus b square. This is what you get when you factorize that. And in the denominator you have x minus 1. You cancel these out. You get x square plus x plus 1. So at first glance it might look like f of x is exactly equal to g of x, doesn't it? Doesn't it look like that? See, g of x is x square plus x plus 1. We've simplified this, we've cancelled out a few terms, and we figured out f of x is equal to g of x. But that's not entirely true. Why? Because two functions are equal, two functions are said to be equal if their domains match and their ranges match, apart from algebraic equality. So, okay, algebraically these come out to be the same, but g of x is defined for all the values of x. Okay, so this point is included. If you look at this, here this is a solid circle. That means this point, I've explicitly indicated this. It wasn't needed, but yeah, I've explicitly indicated this. So this value is included. So there's just a slight difference between these two functions. Still, the limit of f of x and the limit of g of x come out to be the same. I hope you understand why they come out to be the same. Let me explain once more. So, even though f of x and g of x are not exactly the same, their limits at x minus 1 come out to be the same. Why? If you remember, in the very first or the second lecture on limits, in this series itself, we figured out how to find limits using graphs. What we did there was we approached, if we had to find out limits at this point, we approached it from the left side, we approached it from the right side. Whichever value we got, that was the limit. Irrespective of whether that function was actually defined at x equal to 1 or not in this case. If you approach both these functions from left and right hand side respectively, you are going to get the same value of the function, which is 3. In this case also, in this case also. That's why even if at that exact point, even if the function is defined or it's not defined, the limit is going to come out to be the same. The limit is the same. That's why even though, so that's why we can simplify this function. We can cancel out the term in the denominator, and we can say that okay, the limit of both these functions are going to be the same. Since we are dealing with limits, that's all we need. So here's a very important theorem. What is the theorem? It says functions that agree at all but one point, f of x and g of x in our case. So f of x and g of x in our case. Functions that agree at all but one point. They have the same limits at the point of disagreement. Let's look at this once more. We have f of x and g of x. They are exactly identical. Even the graphs are identical. Everything is identical. You can simplify one to get the other. But there's only one point of disagreement. Point of disagreement. And what's the point of disagreement? It's x equal to 1. This is the only point of disagreement. Now look at that theorem. Functions that agree at all but one point. That means functions that agree at all points but not at some specific point. Let's say x equal to 1. They have the same limits we saw just now. They have the same limits at the point of disagreement. Now, this is how you write it formally. You can go through this, take a snapshot, and try to understand what we mean by this. But simply put, this is what the theorem states. Please remember this. See, students, we are looking into the fundamentals, and that's why it's important to know why things work. Okay, it's a valid question. So in examinations like IIT JEE, you might have uh, an assertion reason question saying that f of x is exactly the same as g of x. Most of the students will say yes, that's true, but that's not true. Okay, so why is the limit still the same if both these functions are not the same? Now you know. Now you know that there is a theorem, or even graphically you can analyze and you can answer that. Okay, let's practice one more question, and this is based on factorization technique itself. Let's try to do this. Take a few minutes, attempt this, come back, and then look at the solution. I hope you have given this a try. Let's solve this now. Factorize the numerator. X squared plus x minus 6. So plus 3x minus 2x would work. Let's see if it works or not. X plus 3, what do we have? X plus 3 here, minus 2 x plus 3 here upon x plus 3. This will give me x plus 3 into x minus 2 upon x plus 3. Of course, limit here, limit x tending minus 3, and these two will get cancelled. Now what you do is direct substitution. So put minus 3 in place of x. Minus 3 minus 2. That means minus 5. That's our answer. Okay, minus 5. Okay, so Till now, we saw two techniques. First one was direct substitution, the second one was factorization. And finally, of course, you have to do direct substitution.